Welcome. Should you come across this question in your forthcoming exam, here's exactly how to crack it. And I would like to give credit to WAEC and also All-Inclusive Physics. This was their extract. So the question says, the diagram below represents parts of wave motion in air. If the wave travels with a speed of 300 meters per second, calculate the frequency of the wave. Now, physics is hugely based on your knowledge of on how to interpret the questions. The diagram below, so we have a diagram, represent part of a wave motion in air. If the wave travels with a speed of 300 meters per second, now with your knowledge of wave as regards the FOF I've given previously, you should know that V equals 300, so we represent it as 300 meters per second. Next, they say calculate the frequency of the wave. We are asked to calculate the frequency of the wave, question mark. But we do not have, after this now, we do not have our lambda. And how do we know that we don't have lambda? This is because the formula given to you in the FOF is V equals F lambda, right? So this is the formula to use, V equals F lambda. But in this case, they didn't give us a lambda. Now we need to sort that out by ourselves. Now note, this 3 meters here stands for the distance. This 3 meters here stands for the distance, while the loops here, they represent the wave. Now how do you know how to count the wave now? How the wavelength. So the number of wavelength, this loop represents the number of wavelength. I'll go again. The loop represents the number of wavelength. Now whenever you have a loop, one loop, two loop, this is called one wavelength. I cut it from this place, so like this is one wavelength. One loop, another loop, cut from here, this is the second wavelength. Now you only have one loop here, so this is half wavelength or 0.5 wavelength. So you make use of, in order to get lambda, to solve for lambda, you make use of lambda equals number of wavelength over it's going to be distance over number of wavelength. The distance over number of wavelength. So I'm putting the small symbol of wavelength down here. This lambda will be distance over the number of wavelengths. So we'd say lambda equals, what's our distance? Our distance is 3 meters, right? So we say 3 over, what is our wavelength? Don't forget 1, 2, this is one wavelength. 1, 2, this is another wavelength. Then here is half a wavelength, that is 2.5. So the number of wavelengths is 2.5. So lambda equals 3 divided by 2.5, you get 1.2 meters. Now with 1.2 meters, we've gotten our wavelength. So our wavelength here now, our wavelength is now 1.2 meters. So we'll come back to the formula we are supposed to use. Now recall, we are asked to solve for calculate the frequency. We are asked to calculate the frequency of the wave. So I would make F the subject of formula here. How would I do that? I say V equals F lambda, and I divide all through by lambda in order for F to stand alone. This lambda will cancel this one here, so I'll write it as V over lambda equals F. But in physics you can't write it like this, so you write it, you say F would come first, and you say V over lambda. So most students get this confusing. F, I just brought the F here, here's the equal to sign here, and I brought this one to the other side. Here's the V here over, here's our lambda still here. So what's our V? Our V, do not forget, is 300 meters per second, and our lambda is 1.2 meters. So we say F equals 300 divided by 1.2, and your F would be 250 hertz. 250 hearts as your final answer. Would you like to treat similar questions? Click on the link in the description box. You win. Just believe.